In this, we are going to graph our simple rational functions. If you look at the top of your page, you have the form of your rational function there at the top, p of x over q of x, which is a function like a linear function over another function. Could be a quadratic, could be linear. We're going to stick with linear, quadratic, and cubics. But today in this video, we're going to be following this form, 1 over x. This is our parent function. And so you have the graph here to the side. Notice that you have a vertical asymptote on that y-axis and a horizontal asymptote on the x-axis. Right, that is always going to be the case in these functions. All right, and then everything else you have is going to be these points here. Those are really the only two you need to memorize, 1, 1, and -1, -1. The others you can easily find with an XY chart. Right, if we make this for this left side curve here, we would do -2 and get a -1/2. We have our -1, -1. And then we have, if we did a -1/2, we would be getting a -2. Right, so those are these 3 points right here. Beyond that, you do get into some smaller fraction values past -2, and if you did like -1/4 for the x. All right, on the right side curve, you have basically those same points, except everything is positive. So if you did 1/2, you would have a 2. If you did 1, you have a 1 for the y. And then if you put in a 2 for the x, you would get a 1/2. All right, the main ones you need to worry about are the -1, -1, and 1, 1 points. And then just remember that you have your asymptotes. All right, when we look at these down here on the examples, we're always going to start by putting in that parent function. So I'm going to draw in my asymptotes first. That's always the first thing I want to do. And I will go ahead and put in the 1, 1, and -1, -1 points. Your curves, you can just draw in. There are these L shapes. All right, that's the parent function. The one that we're trying to graph right now is 4 over x, which we could rewrite as 4 times 1 over x to see that that is a vertical stretch by 4. All right, if we made an XY chart here and took these points that we talked about up above and put them in, when I do a 1/2 into this 4 over x, 4 over a 1/2, I'm going to get an 8. All right, I'm dividing fractions, so that 1/2 is going to end up being multiplied by a 2. All right, if I put in a 1, I would be getting a 4. 4 over 1 is 4. And then if I put in a 2, 4 over 2 is 2. All right, so you should be able to see that this point that is at 1, 1 ends up being at 1, 4. The point that was at 1 or at 2, 1/2 ends up being at 2, 2. So we have a vertical stretch happening here, and that shape is going to look the same. All right, the exact same thing is going to happen on the left side piece there. If you know what happens on this one, then you can just do the same thing on the other one, but we'll go ahead and make an XY chart. All right, if we put in a negative, we'll say -2, 4 over -2 is -2. If we put in our -1, we get a -4. All right, so we'll go ahead and start graphing those. There's -2, -2. and -1, -4 is right here. So you can see that the same shape is happening. All right, these are hard to draw because you have so many fraction coordinates, so that right there is enough. All right, on our next one, we're going to start with our parent function asymptotes. Right, they are on the x and y axes. So this one is x equals 0. This one is y equals 0. We know our parent graph has those 1, 1 points, -1, -1. And then if we look at this one, we have a negative sign in our equation. All right, so we could rewrite this as a -6 times 1 over x. And then we see that we have a vertical reflection from that negative sign. Remember, that is over the x-axis. Okay, and then you have a vertical stretch by a factor of 6. All right, let's start with reflecting. If I take my piece here on the left and reflect it, I'm reflecting it up over the x-axis, which happens to be the asymptote. So I'm going to get this piece right there. And then the right side would reflect down and become like that. Right, but I'm also having to stretch this by a factor of 6 vertically. So instead of being at -1, 1, that point is now going to be at -1, 6. So 2, 4, 6 right here. All right, and then same thing happening on the other side. 2, 4, 6. Okay, let's make an XY chart to double check. All right, squeeze that in right here. All right, we're going to use our same key values. All right, if I put in a -1 into this function, -6 over -1 is going to get me +6. All right, that is where I ended up there. Let's do a -2. If I put that in, all right, that is going to get me -2. So there we go. Over -6 over -2, that's going to get me a +3. All right, so this piece is going to have a point right there. All right, and then it's going to continue lowering. We could do a -3 here because that will be a nice point. That will be a +2. All right, so you can see the shape happening here. All right, same L shape. All right, let's put in some positive points. We'll do a +1, +2, +3, and we will get a -6. -6 over 2 is -3. -6 over 3 is -2. All right, so same shape is happening here. Just flipped upside down. All right, so there is our final graph. We'll erase those. All right, all of your functions that fit this form here, whether it is 4 over x, -6 over x, or anything else, a number over x, that's always going to have a vertical stretch, right? And then if there's a negative sign involved, that is always going to be a vertical reflection. All right, take a minute and do the problems that you have on your paper that look just like this.